Hi, let's talk about the types and parts of cooling towers. For the types of cooling towers, we can classify cooling towers according to how airflow is maintained inside the tower. We can classify them into natural draft cooling towers and mechanical draft cooling towers. Natural draft cooling towers uses the buoyancy or the density difference between the incoming air and the exiting air to create air movement inside the tower. These are often used for the largest cooling applications, such as cooling water for power plants. Mechanical draft cooling towers, on the other hand, utilizes mechanical fans to force air into the towers. These are often used for intermediate-sized water cooling applications. Let's consider natural draft cooling towers. Natural draft cooling towers maintains airflow through the use of buoyancy, or the density difference between the warm exiting air and the cold incoming air to create a natural movement inside the tower. The main factor affecting natural draft cooling towers is the approach. At sufficiently low approaches, large towers are needed in order to sufficiently cool the water to the required temperature. We can describe the approach as the difference between the cold water temperature and the wet bulb temperature, as can be seen in the illustration here. The advantages of using natural draft cooling towers over mechanical draft cooling towers is that there is no pump or fan to power. Also, when the wet bulb temperature is lower than the existing water temperature requirement, the amount of circulating water can be decreased. The major disadvantage of using natural draft cooling towers is that if the wet bulb temperature is higher than the required existing water temperature, there should be provisions made to supply cold water to the tower to sufficiently cool the water to the required temperature. We can classify natural draft cooling towers into atmospheric circulation or louver type, or chimney or hyperbolic type. The first type is the atmospheric circulation or louver type cooling tower. In louver type cooling towers, air flows horizontally through the tower. Water is brought about by flat boards laid down. The boards in one layer lay in one direction only, and the packed portion occupy the entire length of the tower. Here is a picture of an atmospheric circulation or louver type cooling tower. Here is another picture. The other type of natural draft cooling towers is the chimney or hyperbolic type. In chimney or hyperbolic type cooling towers, the air flows through the opening at the bottom of the tower and leaves at the top of the tower due to upward draft. Zigzag slats are used to minimize decrease in airflow. The packed portion occupy only a small part of the tower, and the hyperbolic shape saves concrete and construction, accelerates upward convective airflow, and improves cooling efficiency. Here is a picture of an actual hyperbolic type cooling tower. Natural draft hyperbolic type cooling towers can be subcategorized based on the relative air-to-water flow directions. We can categorize them into cross-flow design, where the airflow is directed perpendicular to water flow, or counterflow design, where the airflow is directed opposite the water flow, as seen in the pictures. Let's now proceed to mechanical draft cooling towers. Instead of utilizing the density difference, mechanical draft cooling towers uses mechanical fans to force air through the towers. These are often used for intermediate-sized water cooling applications. Mechanical draft cooling towers are affected by the approach, the cooling range, the quantity of water to be cooled, the wet bulb temperature, the air velocity, and the tower height. We can define the approach as a difference between the cold water temperature and the wet bulb temperature. And the cooling range can be defined as the hot water temperature minus the cold water temperature. Using mechanical draft cooling towers can be an advantage in areas where wet bulb temperature is high and over a long period of time, and in areas where power costs are low and maintenance crew is available. Fans cause increase in contact time between water and air to maximize heat transfer, and cooling rates can be controlled by adjusting fan speed and diameter of the fan. This illustration from Berry illustrates the different capacities at different fan speeds and diameters. The disadvantages of using mechanical draft cooling towers include the need to maintain the added components, such as the fans and pumps, and that the tower can be subject to the circulation of humid vapor. We can further categorize mechanical draft cooling towers into forced draft cooling towers or induced draft cooling towers, depending on where the fan is located inside the tower. In forced draft cooling towers, air is forced in at the bottom, where the fan is located, and flows out at a slower velocity at the top. These towers are only operated in counterflow fashion. Forced draft cooling towers can be installed indoors and in confined spaces. The tower isn't subject to the circulation of humid vapor, and fans can be placed outside the cooling tower itself. The fans, however, are more susceptible to freezing conditions, especially if the dry bulb temperature of air is very low. Also, higher power is required to run a forced draft cooling tower versus an induced draft cooling tower. Here are some pictures of forced draft cooling towers. You can notice from the pictures that the fans can either be located at the bottom of the tower or protruding externally from the side of the tower. In induced draft cooling towers, the fan is located at the top. The air enters via the bottom or the sides and leaves at the top with a higher velocity. Here is a picture of an induced draft cooling tower. The advantages of using the induced draft cooling towers is that no humid air is recirculated back into the tower due to the high exit air velocity. Induced draft cooling towers are usually placed outside, so they must be made from durable materials. Induced draft cooling towers can either be cross-flow design or counterflow design depending on the relative air to water flow directions. In cross-flow induced draft cooling towers, the air flows perpendicular to the water flow, while in counterflow cooling towers, the air flows opposite the water flow.
For the parts of the cooling tower, both natural draft and mechanical draft share common parts. These are the water distribution system, tower shell and water basin, inlet and outlet pipes, tower fill or packing, and the provisions for air entry or exit. For the water distribution system, this allows the entry and distribution of hot water into the cooling tower. This can either be pressurized nozzles, sprinklers, or sprinkler pipes. Next would be the tower shell and water basin. Tower shell is the external structure of the cooling tower, and the water basin is the one that collects the cooled water after the process. Most of the parts of the tower shell and water basin are made of plastic reinforced with fiberglass. This allows a rust-free and long-term performance, even under the most severe environmental conditions. Next would be the inlet and outlet pipes. The inlet pipes carry the hot water into the cooling tower, while the outlet pipes carry the cold water out. This is connected to the piping systems of the plant. Next would be the tower fill and packing. These are located within the cooling tower where hot water coming from the sprinkler pipes pass through and comes into contact with the air. These fillers tend to increase heat transfer through increase of both contact time and surface area. There are two types of fills. The splash fails, which increase the heat transfer between water and air by dividing the water into fine droplets through splashing. And the film fails, which are generally made of plastic in a honeycomb structure and have a higher efficiency than splash fails, because this causes the water to spread into thin films. Last common part is the provision for entry and exit of air. These are devices such as windscreens or louvers, where cold air enters and hot air exits. Some inlet louvers are made from non-corrosive PVC, and this prevents debris from entering the water basin. For the additional part of a mechanical draft cooling tower, these are fans and motors. The fan and motor used to generate air movement in mechanical draft systems. It is usually weatherproof and totally enclosed to minimize noise due to motor function and to ensure a more efficient and long-term performance. So for the overall process of a cooling tower, this is simplified into this figure.